Hey everyone. So in this video we're going to be controlling an air duct damper. So maybe you've got a room in your house like a spare bedroom, or maybe you heat and cool your garage, but you have a room in your house that maybe gets excessively hot or excessively cold, or you don't necessarily want to waste a lot of energy on. Maybe you have your heat set on 75 degrees and you wouldn't mind if this room got down to 60 or something. So by shutting the airflow off to that room, we can actually save quite a bit of money on our electric bill. So that's what this application is all about. We have an air duct damper here that's electronically controlled that will open and close and allows air into the room from your HVAC, or shuts it off so that it's not consuming excessive energy. This air damp controller takes 24 volts AC to operate, which is a common voltage in HVAC industry. So this damper actually comes with a 24 volt AC transformer that you feed 120 volts AC into, and it converts to 24 volts AC to control the damper. So we've got our power coming in here, 120 volts AC, and what we're doing is we're switching the hot leg of that 120 volts AC on and off to this transformer using a relay. And that relay is going to be controlled by this particle photon module. So this allows us from the cloud to be able to open and close this damper. So that's the first part of this application, is basically controlling the damper open and closed. The second part is monitoring the temperature in the room that you're controlling. So for that, we have a particle photon module installed and an I2C shield connected to an MCP 9803 temperature sensor. This is going to allow us to get temperature readings from the room and then control that damper accordingly. So in the firmware running in this temperature module, this is actually where most of the work is done. What we're doing is we're reading the temperature. We're setting a set point temperature that we want to keep the room set at, so maybe we're just going to set this room to 60 degrees. We can also program a temperature swing. Most of your common thermostats have a 1 degree temperature swing. So if you have your heat set at 75 degrees and the temperature drops down to 74 degrees, it's going to kick on. And you can't control what that temperature swing is. But in this firmware, we're going to be able to set that temperature swing to anything that we want. So we can say, that room can get down, 5 degrees below the set point before we actually open the damper. And that is fully adjustable. So let's go ahead and dive in here. In this application, you're not going to have to write any code. All of the application has been submitted to the Particle Build Web IDE so that you can load it up and flash it right into your controllers. All you need is the hardware, a little know-how, and a computer. So let's head over to build.particle.io and sign into your account. If you have not already done so, make sure that your modules are set up for your Wi-Fi network and are associated with your Particle account. If you have more questions about how to do that, you can head over to docs.particle.io, and they have instructions on how to do that. So at this point, your modules should be online. They should be associated with your account, and we'll get started. So like I said, head over to build.particle.io, and once you're there, we need to make sure our devices are online. So click on the target icon over here to list your devices. I currently, my two devices are called Duct Relay and Duct Thermostat. Duct Thermostat is the module that has the temperature sensor connected, and Duct Relay is, of course, the board with the relay on it that's actually going to control the duct. So make sure Duct Thermostat is selected here, indicated by the little star icon on the left. Once that's done, click on Libraries. And under Community Libraries, we need to search for MCP 9803. And that will bring up the MCP 9803 library that we have submitted here. So go ahead and click to select that. And there's a couple of examples in here. You'll want to make sure that ductthermostat.ino tab is selected. Once that is selected, click the Use This Example button. Okay, now once that's forked over, we can go ahead and flash the firmware. Our device is selected, we've got the correct firmware loaded, so now we just click the flash icon here in the upper left corner. And you'll see the magenta LED on your module flash indicating that it's being flashed with the firmware. Then it will reassociate with your Wi-Fi network and finally reassociate with the particle cloud. At that point, this controller is all ready to go. Okay, so now we need to flash the firmware into our relay controller module. To do that, go back to Devices, select the module that is plugged into your relay controller, then click on the Libraries button again, and now we need to search for NCD1 relay. Once that comes up, click to select it. And here we're going to need to make sure that the duct-relay.ino tab is selected. By default, Cloud Control is going to be selected, so you want to make sure and switch that so it's duct-relay.ino is selected. Once that's selected, click Use This Example. Okay, once that's selected and you have your device selected, go ahead and click the flash button. And we'll see the magenta LED on our board. It'll power cycle, reassociate with the Wi-Fi network, and finally it'll reassociate with the particle cloud. Okay, so we've got the firmware running in our controllers. We're ready to go set this thing up. To set it up, we're going to use Mobicle. So head over to mobicle.io. Once there, sign in with your particle credentials. And we'll see our two devices listed here. We want to select the module that is installed in the temperature sensor board. For me, that's duct_thermostat. And here, after a few seconds, you'll see the variables for the module. It's going to tell you what the current temperature is. It's going to tell you whether it's on AC or heat. It's going to show you the set temperature, and it's going to show you the temperature swing. So to make adjustments to set temperature and temperature swing, we're going to click on the set temperature function down here. And we can go in there and we can enter whatever we want. So right now, the temperature set is at 74.75. Our set temperature is 77 degrees. So right now the temperature is actually cooler than what our set temperature is, and we're on AC, so the duct is not open. So in order for that duct to open, we need to be it needs to be at least 2 degrees warmer than the set temperature. So let's change this to 72 degrees and send that. And now we'll see the relay clicked on the board, and our duct will start to open. And it is a little bit slow to operate. And eventually that will open up and that will allow air to flow into the room. Now this does not kick on your HVAC unit. This simply opens the duct to allow air to enter into the room. We can change from AC to heat, and we actually do that by publishing an event. And the reason we do it like that is because this firmware was written so that you can actually have multiple boards installed throughout your house. So rather than having to go into every single board and change whether it's on AC or heat, we're going to publish a variable that all of those boards can monitor. So we'll go back to the device list, and we're going to click on the plus button next to Event Publisher. And here we're just going to name this button Turn on Heat. And then we need an event name. That event name is registered in the controller. So if we go back to our code and we take a look at the duct thermostat code, we can see that it is subscribed to a function, or subscribed to an event named HVAC_mode. So if we copy that, and we can see we need to set that to either heat or AC. So let's go back over here, and we're going to enter the name, which is HVAC mode. The data we're going to pass is heat, and we're going to set the time to live to, let's say 120 seconds. So it'll be up there for 2 minutes for the controller to get. So we'll click submit, and then we can click on that. And you'll see that our duct closes. And that is because it is now on heat, and this HVAC variable here will update here in a second. But since the temperature is 74.86 degrees and our set temperature is 72 degrees, it's already hotter in the room than what our set temperature is. So that's about all there is to this application. This is just this is a simple entry for this type of application. You could install these ducts all throughout your house and control them. You could also put a relay where your thermostat is so that the system can actually kick your HVAC unit on and off. And then these thermostat boards, these temperature sensor boards, could actually send requests to the thermostat to kick on. If you wanted to do that. To do that, you would really need to do a whole house system. You'd have to have one of these ducts on all of your HVAC lines to supply your rooms, and you'd need to be able to control all of them to do that. So this is kind of a really simplified version of it, basically for a single room that you need to save some money on. You know, like I said, like a spare bedroom that you're never in, or your garage maybe. So that's kind of what this is. You can get these duct dampers from Amazon. They're really not too expensive. This is the one that I have. It's showing up for $75 here, free shipping. And this is a 6-inch duct damper. It's the ZC106. If you change that to ZC108, they also have an 8-inch version. I think they've got several other sizes as well. You can also, I think, purchase these as normally open or normally closed. So that's another thing that you can take a look at. The controllers that we used in this application can be found at ControlEverything.com. Here's the one-channel relay controller. And for a limited time, it is shipping with a free particle photon module, so that's a really good deal. And this is the temperature sensor that we're using. It's the MCP9803 mini module. And that simply hooks up to the particle photon through this I2C shield. So if you guys have any questions on this, be sure and let us know. But yeah, install one of these and let us know how it goes for you. It looks like it would work really well. So thanks, and have a great day.